Broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and thank you for joining us today. My watch says 2 o'clock, but we're going to wait a few minutes just to make sure everyone has joined just before beginning. So we'll begin in about 2 minutes. Thank you. All right, my watch reads a few minutes after, so we'll go ahead and get started. Good afternoon, everyone, and thank you for joining us in the second webinar in the Conversations with Colleagues series, which is being hosted by the TRV Bicycle and Pedestrian Data Subcommittee. These webinars take place every fourth Tuesday of every other month, and are focused around challenges in bicycle and pedestrian traffic monitoring. My name is Nathan Hicks, and I'm a transportation planner with CDM Smith, and will be assisting with the facilitation of today's webinar. Joining us, we also have Peter Olms, a research scientist at Virginia Transportation Research Council, and Frank Pearl, who's also a researcher at Tool Design Group.
This is Peter. I guess if you want me to reintroduce myself anymore, I'm with the Virginia Transportation Research Council. We're the research division of the Virginia DOT. And we're interested in this topic because we're doing some explorations into what a statewide count program will look like. And so we're working on writing up the results of a survey of local and regional governments in Virginia about bicycle and pedestrian counting.
And this is Frank Pearl, just to give a little bit more of an introduction of myself. As Nathan said, I'm a researcher at Tool Design Group, where I work on safety analysis projects and bike and pedestrian count program development.
Great, thank you, Peter and Frank. We also have a few others in the background, Sarah O'Brien, as well as Brittany Gick and Miley, who will be facilitating within the background of the webinar today. And today we'll be focusing on the technologies that are being used to count bicyclists and pedestrians, such as inductive loops, pneumatic tubing, and infrared monitoring systems. We want to review them briefly and then allow for discussion following those topics. We'll also be discussing new and emerging technologies, such as processing count data in real time using video and other automated systems. We also want to note that we don't want to specifically mention any vendors today and are more trying to talk about the specific technologies themselves that are being used to count bicyclists and pedestrians. And before we begin, we'll go over a few ground rules here. Just as in the previous webinar, the aim for this series is to allow for a more conversational tone. The hope is that as the discussion progresses, questions can be raised not only to the speakers, but to one another. If you have a question, you can either type it into the question pod, or you can raise your hand on the interface and we can unmute your microphone so that you can speak and ask a question. And at this time, let's go ahead and test the raise your hand feature. So if everyone could please go there and test out raising your hand. Looks good. I see a bunch of hands being raised. All right, great. Thanks, everyone. So if you have a question and you would like to speak and use your voice instead of using the chat pod, just do that and we'll be monitoring that and we can do that for you. If you have any audio issues throughout the webinar or any other technical problems, you can use the chat pod or the question pod and let us know. Brittany from TRB will be assisting and monitoring those issues in the background. And following the webinar today, we'll be providing a summary which will include any links or references that are made throughout the webinar, which Sarah will be posting periodically while we're presenting today. And at this time, I will hand the presentation over to Frank.
Thanks, Nathan. 1 second
You
here.
should be presenting now.
Yep. Okay. I should be showing my slides now. Are we
Yes,
live?
we can see them.
Okay. Cool. So I want to kick off this discussion today with a little presentation here, just very brief, primarily focused around a study that I worked on a couple of years ago, NCHRP 719, and as probably a lot of you know, the main result of that was NCHRP Report 797, Guidebook on Pedestrian and Bicycle Volume Data Collection. This is a great resource if you haven't looked at it already for just information generally on collecting ped and bike volume data from what technologies to use, to how to develop a program, to how you might want to think about analyzing your data. This was a project led by Kittleson and Associates, and our team included UC Berkeley SafeTrack, where I was at the time, Tool Design Group, and the University of Wisconsin-Milwaukee. Since NCHRP 797 came out, we actually completed a follow-up study, which was released, I believe, last December as NCHRP Web-Only Document 229. That has updated results, revised models. So we redid all our analysis and corrected some errors in the original publication. We tested a few more technologies and collected more data in the field testing component of the study. So that is a good thing to check out if you haven't seen it already. And because it's all written up nicely there, I don't want to go through all the results in too much detail here. As the goal here is really just to have some conversation between everybody. So main point I wanted to make here is, in thinking about what technology is going to be best suited to your particular counting exercise, you've got a number of decisions to make. And the result of these decisions is probably what is most going to govern which technology is most applicable to your counting. First of those is whether you want to do permanent or short duration counts at a given location. So permanent counters, of course, are counters that are installed in the ground or to a fixed object and aren't moved around, whereas short duration technologies are designed to be moved between locations to increase spatial coverage of your count program. Whether it's a screen line or in an intersection count that you're interested in doing. Unfortunately, most of the technologies on the market currently don't handle intersections particularly well for bike and ped counts, so we're largely looking at screen line counts, but that is something that you need to think about in picking your technology. Next, what mode specifically you're interested in. So whether you just want a count of bicyclists, whether you want a count of pedestrians alone, whether you want bikes and peds counted separately, or whether you want that mysterious pedestrian bicycle counted, which is where you have just a count of all active transportation users crossing a location. Finally, different technologies are better or worse suited to particular monitoring environments. So if you're looking at a multi-use path or a trail or an in-street installation or a sidewalk will also help determine what you need to be working with.
Frank,
in the end, yeah.
I'm not sure your slides are still showing the right way. Are you intending to just your initial slide now?
No.
Now I see 4.
Is it in presenter view or is it in
PowerPoint?
Is it in slideshow mode?
Not yet.
No, it's still on the editing pane.
Well, that's odd. How's that?
There we go.
Better?
Yes.
Cool. Okay, so now I'll just briefly talk through some of the technologies that we tested in that NCHRP study to give an idea as to what some of the testing that's been done has covered, and that'll hopefully give us a discussion point for other tests that may be ongoing. So first, we tested a number of short duration count technologies. Pneumatic tubes are, of course, the primary tool used for counting bikes and cars on a short duration basis. If you're looking at anywhere from a day to a 2-week count window, you're probably looking at pneumatic tubes. There are different tubes available for specifically manufactured for counting bicycles. And one thing we noted in the study is that those tend to work a little bit better for counting bikes. We didn't have extensive testing of pneumatic tubes in shared traffic configurations, so in places where bikes are mixing with cars, although there was a little bit of that. But that I think is a more complicated environment where having those bike-specific tubes are particularly important. We also looked at passive infrared and active infrared counters. Both of these just give you a total user count, and when paired with a pneumatic tube counter in a mixed bike and ped environment can give you a separate count of pedestrians, but they don't by themselves do that. And finally, we looked at some short duration radar devices. We didn't have as good of luck with those. And this really, I think, pointed in part to the need to very closely follow manufacturer directions in doing your installations to make sure that you're installing everything properly, as it's possible that we didn't get that quite right. On the permanent bike counter side, we looked at induction loops. So these are the loops you see here in this image dug into the pavement. Those generally worked pretty well, although carries with it the caveat that it only counts things that actually go through the detection zone. So if you have induction loops installed in a place where there's high likelihood of bicyclists riding outside the bike lane, for instance, you need to be mindful of that in analyzing your data. We looked at piezoelectric strips particularly in off-road path locations, and found that they worked very well in that setting, although we didn't do any on-street testing of those. We tested a radar device in an in-bike lane environment and didn't have as good of results there, but it seems like there might be some potential. And finally, we looked at thermal imaging, and in our test, we found that that worked well in a somewhat constrained environment of a cycle track, although I know there have been other tests that haven't been quite as successful in more mixed traffic configurations. And then finally, the passive and active infrared both work as well for counting pedestrians in those off-street types of environments or sidewalk conditions. And we looked at some of those in the study as well. So with that, I think I'll open it for discussion. And I think Peter has some slides as well. I don't remember how we wanted to structure this, but when we get to discussion, I wanted to see what everybody has worked with, what works well for them, and if there are any other large-scale tests going on. So
okay,
I
great.
don't have slides. Let's just talk.
Cool.
Yeah, I think that's the idea. We'll have a 15 to 20-minute discussion about all this and then move on to Peter's portion. And I'll go ahead and make myself the presenter at the moment. Okay. So do we have any questions in the question pod right now?
I don't see any in the question pod right now.
Okay. Well, I'll go ahead and open it up with one. Frank, in regards to all the different technologies that you were testing, which ones did you feel I guess were the simplest in terms of ease of use, either in installation or in understanding?
I mean, it really depends on what you're doing. You know, permanent counters are typically more complicated to install just because they require pavement cuts typically if you're looking at permanent bike counters, or they might require digging a hole to sink a post, for instance. And as many people have found out, that can trigger the need for additional permitting, which can add to the complexity. So generally the permanent counters are more difficult to install, and the short duration counters are hopefully fairly easy to install if you're planning on moving them around frequently. And that generally was the case with everything we looked at.
Somehow it seems like everybody's gotten muted. Hold on just a second. I'm trying to see.
Yes, I'm not sure how that happened. I just
Okay.
unmuted myself and Frank.
Okay.
Yeah, Frank. Sorry there, Frank. You got cut off halfway through your sentence.
Which sentence?
I think it was the last portion of your sentence, of your last sentence.
Okay.
So, but that makes sense.
Generally, the point was the permanent counters are typically a little bit more complicated to install and might require some specialized knowledge, such as more wiring, like electrician type work, or the ability to cut into pavement. Whereas you can assign a grad student to install the short duration counters.
Right, of course.
All right, we've got a question from Pamela, and I can go ahead and read that, and we can also unmute her line. Has anyone attempted to measure both bicycles and motor vehicles on roadways where there are no bicycle lane markings? So bikes are not necessarily in a separate lane.
So this is Sarah, so I can speak a little bit to that. We've attempted to do that, and I will say that it is more difficult to get accurate counts when you are in a shared lane type of facility. Even with a permanently installed counter, we're using the inductive loops as the technology, and it seems like it's dependent upon the motor vehicle volume in relation to your bicycle volume. So if you have a really high bike volume location and it's a relatively low motor vehicle location, then the error, you might be able to overcome the error of it in precisely overcounting by counting by counting motor vehicles. But to give you a specific threshold to say, you know, don't put it on roads that have X volume of cars, we don't actually have that answer yet, but it does seem to be some sort of ratio between the two. And definitely in places where we have relatively low bike counts with relatively high motor vehicle counts, we have more difficulty in having accurate bike counts with the equipment.
Thanks, Sarah. This is Pam, and just a follow-up to your answer. How did you configure the loops to do this? And what I'm thinking, I work for the National Park Service, and one of the issues we have is at entrance stations at parks. We can count the vehicles coming in, but we have some parks that the gate is closed in the off hours, and we have people riding their bicycles around them, and we would like to be able to count those folks, but we're trying to figure out how to do a permanent installation that picks up vehicles and bicycles. I was just curious how you said you used loops. What sort of a configuration did you use?
Sure. And just before we move on, can everybody else hear me?
Yes, we can.
Okay, all right. I just saw the note from Frank, so I just wanted to make sure we didn't somehow get muted again. Yeah, so we're installing them based on the vendor specifications, but I will say where you have a location where it's a shared lane and you don't have a designated bike lane or a designated place for the bicyclist to be riding, you really have to kind of anticipate where the bike alignment will be in the lane or in the multiple lanes that you might be wanting to count them in. So in some locations we have 2, you could potentially do even 3 diamond shapes, or the shapes that we're using, that would be, I guess, you know, one right next to each other or beside each other to essentially cover the width of the road or the lane that you're trying to cover. But of course, that also means that you're going to probably have more motor vehicles going over that as well, the wider the lane width you're covering. So I think it really depends on your specific site. And if there's a place where you could count using separate technology from motor vehicles, that you want to count both motor vehicles and bicycles, but you want to do them separately, you could potentially consider putting that count technology for your bicyclist in a different location where you know you're going to have a more focused or funneling point specifically for the bicyclists. That's one option. Definitely we avoid turn lanes, or we try to make sure that we are back far enough upstream from where a left turn lane might be, for example, so that if you've got bicyclists that are going to be turning left, you want to catch them basically before they're migrating over to the left side of the lane or into a separate lane. So we're still trying to get them basically where we expect the bicyclist to be riding in the street.
Thanks. That's kind of how I was thinking about it, but I was just curious if anybody had actually done one of these outside of just the thought process, which is where we are. Thanks.
Mm-hmm.
John Leeswin is unmuted now and may have some additional quick thoughts to share on that.
Yeah, hi, calling from New Zealand. Pam, it sounds like you have a few different technologies that you might try. You could try the Iterra Smart Cycle camera. I haven't done it myself, but I've recommended it to a couple of agencies, and one has just done an installation, and I'm going to try to publish the results of an accuracy study. So we'll be comparing it with tubes and manual counts. So that's at a bridge location, which would be similar to your gates. So just a suggestion there. Also, I did 17 sites in Columbus, Ohio, and a number of those I did with EcoCounter Zelt cycle-specific tubes, and they were in mixed traffic environments. So basically, the tube was run from curb to curb, and we were looking at the data that included both car counts and bike counts. And although I wouldn't hang my hat on our accuracy tests, because the length of time that we did a calibration, or actually more accurately a validation, was just a half-hour manual count, just watching the tubes, and the results of that were very good. One problem with those tubes, though, is that, like has been already mentioned, if you locate it anywhere near turning traffic, the tubes don't really hang on too well. So you've got to go past the site numerous times to make sure that, that the tubes stay in the ground. And it really depends on the type of asphalt, too, and the nails that you use. I think that's it. Oh, there's a third approach, Frank. You mentioned permanent counters, and then you mentioned short duration counters. And you're primarily talking about doing tubes for short duration, although you mentioned a couple of other possible technologies, like I used a bunch of mobile infrared cameras to capture all traffic, bikes and peds. But you can also install permanent sensors and just leave the hand well empty and then rotate a logger through that. So I call that a mobile counting program. And basically that means that you can purchase less of those expensive loggers and cover more sites, but you're using inductive loop technology.
It's a great idea, John. I haven't thought of doing that.
This is Krista. Can I say a few things about tubes, or would we want to move on?
No, go ahead.
Okay, this is Krista Nordback. I spent some time with the team at Portland State University and also with the folks at Boulder County studying counting bicycles and motor vehicles with pneumatic tubes. And in Boulder County, they are continuing to do that, and I think also maybe in Hennepin County using the MetroCount product. And they discovered that they were actually counting motor vehicles and bicycles even when they only thought they were counting motor vehicles, because the bicyclists were being misclassified as motor vehicles. So it looked like their number of trucks were being inflated when actually those were bicyclists. So in places where there are a lot of cyclists and you're conducting motor vehicle counts using tubes, that's something to be aware of, is that your tube count might be wrong for motor vehicles because you're not properly classifying bicycles. But the good news is that there are ways to properly classify the bicycles, and there are multiple products out there right now that can do that. But when you're looking at bicycles in mixed traffic, as others have mentioned, you're always going to have a little more error than you would have if they were separated. So it's not something to just take lightly. It's definitely something to look into and spend some time to look at the research. There's certain schemes that work for these types of devices, and there are a lot of ways to do it wrong. And we worked with Oregon DOT, and they used their standard equipment and methodology, and they were missing. They were only counting 30% of the bicycles because their setup wasn't set up for bicycles specifically. So it's very important to spend the time to figure out exactly how to do it correctly with the equipment you have.
Yeah, Krista, that's a great point. I think MetroCounter is an Australian product. I know that most of the agencies here in New Zealand use MetroCounters, and the New Zealand classification scheme seems to be pretty good on differentiating cars and bikes. Of course, it's based on axle counts and the spacing of the hits. So a bicycle obviously has a lot shorter wheelbase than a car. And then in order to filter out motorcycles from bicyclists, they make an assumption on the speed. So if it's over 30 kilometers or 20 miles per hour, they sometimes classify that as a motorcycle. And of course, that's user adjustable. So if you have a lot of lycra-clad people, you might set the speed higher, and you might end up capturing a few motorcycles in there. And of course, where you locate, you don't want to locate near a stop line where the motorcycles and the bicycles are probably going the same speed. But Krista, you're totally right. It's all about the classification scheme, and you can start with the New Zealand scheme and just adjust from there. Just an idea.
And Boulder County also has their scheme that they came up with published, and that's available for free online as well. And MetroCount has done a lot of development in the last few years to improve their scheme, and I haven't tested the latest version that they've come up with.
Okay, great. John, Krista, thank you. I don't see any other discussion at this time regarding this particular topic. So we're going to kind of shift it a little bit more to cost specifically. And what technologies seem to work well in terms of low cost and high cost, or which ones do cost the most. And I actually had a question regarding that for you, Frank, or for anyone else really. I've seen some mentions before of using a sort of a trail camera or a hunting camera as another option for counting bikes and peds on trails, where different kind of device may not be applicable, and it seems to be more of a low-cost option. Has anyone in particular done that? And David, Pat, I do see your question or your comment about not wanting to specifically mention company names, and you are correct. We do want to more focus on the technologies themselves and not the vendors, but like you do say, it is hard to kind of avoid that.
Yeah, I used, this is John again, I used an active infrared camera. Without mentioning the name, I can just say that it was rather hard to set up. It was inexpensive. The cost was $700 per unit. You get them in quantities of 3 at a lower cost. But the setup is rather difficult because it relies on legacy ports that a lot of computers don't have. And the software interface was really clunky. But in the end, you can get the output in Excel. So the benefit was low cost. The disadvantage was a fair amount of labor time.
Thanks, that's good to know, because I have seen that mentioned quite a few times by people, and they always wonder if that's an option. And I think sometimes the processing of the data afterwards is something that is very important, and sometimes can be missed, especially whenever there's so many different types of vendors and technologies out there. And I do also just want to...
I only found one technology, so it would be interesting to find out if there's something more modern out there. But the field setup was really time-consuming too, to make sure that you had that you weren't capturing every leaf flutter.
Right, exactly. Because with the infrared, that could be a possibility. And I do want to make a note to everyone as well. We've unmuted most of the attendees. So if we caught you unmuted, we apologize. If you want to go ahead and mute yourself back over again, feel free. But if there's any other questions in regards to costs or specific costs in regards to technologies, ones that you found, or specific technologies that you found that work well, those will be particular topics or questions to ask one another.
Those hunting infrared cameras, just a bit of advice. Go to Home Depot or Lowe's or one of those type home improvement stores and get one of those very low cost, I think they're like less than $20, electrical shutoff box. They're like a gray metal, and they're the perfect size to set the sensor and logger unit inside. The active infrared, you don't need. Actually, I might be confusing myself. Frank can probably clarify this. It was over 3 years ago. So, but anyway, yeah, there was a sensor on the other side. But anyway, those things have a locking feature, so you can just hang a padlock on it, and then you can strap it with a metal strap to a tree or a post or a fence, and that just helps ensure that nobody's messing with your logger.
And I'll say, this is Sarah, we have a similar type setup with cameras that we actually use for validating our continuous count locations. So at our continuous count locations, we have the infrared or the inductive loops, depending on what it is that we're trying to count. But we basically also count for a short amount of time to validate the machine counts with these small bullet cameras. And it's a similar kind of thing. We've got a ammo box that sets, down at the bottom that has the DVR in it that we program so that the camera is only operating during daylight hours, and we can tell it, which days of the week if for some reason we didn't want to do it consecutively or something like that. And the battery sits in that as well. And then the camera can be mounted up, high on a pole or a tree or whatever you have, or a mounting pole. So we use that as a temporary way to validate, but it also could be a tool to actually collect short duration counts at a location. And then we have, because I work at a university, we have students who process the data that comes in.
Great. Out of curiosity, roughly how many continuous sites do you have?
I've lost count at this point. We're in the middle of installing our phase 2 batch of counters. So we have roughly half of those in. I want to say we're maybe around 30 or 40 counters, but not all of them are at individual locations. So in some locations we may have 2 count systems to become one station. So, for example, if you need count data, if you need to get count station sites on each side of the road, so that you can get pedestrians on either side of the road and bicyclists on either side of the road, then you might have to have 2 separate units or systems for counting, and then we have to aggregate that data to get us the screen line counts for that station.
Okay.
Frank, this is Peter. I don't see any questions in the question pod right now, but I want to go back to installation for a moment. Are there sort of issues with installing any of the types of technology where a locality wouldn't know how to do it, or are they typically things localities are already good at doing? Do you have to be kind of a larger locality to have the skills to install, say, a saw cut for a loop, or is it pretty much simple?
It's not necessarily super simple. I think it does depend on what capabilities your DPW might have in-house. Definitely some places would want to just hire out that saw cutting procedure to a contractor. So it really depends. There is with some devices, there is some degree of precision needed in doing that install, where there's less with others. For instance, the piezoelectric strips need to be installed pretty close to spec if they're going to work properly, from what I understand.
Thanks.
I actually do have a comment on that as well. It's not in regards to permanent installation sites, but the Palm Beach MPO, they worked with their own county engineering department to move the mobile counters around while they were doing their program, and they're moving them all throughout the county. So they partnered with them and had them or used their traffic monitoring experience and their know-how of the area. So this always could be a potential option, is to look within the county, may not be within a planning agency or something like that, but there could be other options or other potential options for municipalities or whatnot.
I'll say the other thing that, as far as contractors versus doing it in-house, I mean, I agree that a lot of it does depend on what level of service your public works folks may be providing. Like, for example, if they can install signals and they do the same kind of saw cuts for that, then they probably have the equipment and the experience that they would be able to do that in-house. But the flip side of hiring a contractor is some of the problems that we've run into is if there's one municipality, for example, that's installing one counter or just a small number of counters, sometimes it's difficult for them to get a decent bid, a cost estimate from contractors to do that work. And so we found that some localities want to kind of pool in together, like for example in the capital area, MPO region of North Carolina, they decided instead of doing individual counters that would be the responsibility of each individual agency to install, they're funneling it through the MPO to help streamline some of that and get some efficiencies of scale with hiring a contractor.
Thanks. That's interesting. I think that could apply in cases where maybe you've got a university that would want counts but doesn't have control of roadways, doesn't have the kinds of folks or skills that would be installing that, but might have an adjacent locality that would.
Sarah, can you also mention how you guys at the university there are kind of helping out the contractors or being on hand during the install? That was my understanding, because I think that's a really good thing.
Yeah, so in general, I would say that when you're installing vendor equipment and you're responsible for installing it to specification, there's two ways I would go about that. One would be to actually, as part of your contract with the vendor, to potentially, this for permanent installations, to potentially ask the vendor to actually be on site, and they are essentially going to be serving as quality control for their own product to make sure that it is installed to specification, so that if there's any malfunctions, it's really clear that it wasn't something related to how it was installed itself. And so secondarily, what we've been doing for the state of North Carolina is when we did the very first round of installations, we actually did have the vendor on site with us, and we essentially got trained up on how to do the installations. And now ITRI essentially serves as that quality control component. So we as what am I trying to say? we're working for NCDOT to help them establish their program, but NCDOT does not install the equipment, and ITRI technically does not install the equipment. It's the municipality that is part of that gets rolled into NCDOT's program, and they get equipment from NCDOT, but it's the responsibility of that municipality or agency, and MPO in other case, to install the equipment. And so what ITRI does is essentially serve that quality control measure to make sure that they are installing it to specification in the location where it needs to be installed. And then we basically coordinate with the vendor on troubleshooting any maintenance that comes up in the first 2 years to work out any bugs that might be present.
Thanks.
Hi, this is John. We also allow a amount in our budget for Palmerston North where we have 17 permanent inductive loop plus infrared thermal, infrared/thermal counters. We have 17 of those and then 35 mobile sites. And so we allow a figure of about $400 US per year per site for the first 2 years for setup issues and also for the monitoring service. And that also pays for the cell phone, what's called GSM monitoring. So it's not just obviously the capital and initial installation cost, but also to allow for maintenance and monitoring and the cell phone per site.
Okay, great. We're going to stay with this topic with current technologies and the the last portion of this, we're going to talk about accuracy between the various technologies and what, if any of you have used these different technologies, what you found have been the most accurate or least accurate, or what situations possibly have caused a loss of accuracy. And so if you have any particular topics or particular technology that you want to make a note of, you can use the questions tab and make a note of those, and we can let you discuss those more and unmute you.
Some of the things I've found that affect accuracy include the surface that the loops are installed within. We have a number of counters that are installed on what we call limestone pathways. That's basically a crusher fines path. And when the path erodes during the winter storms and the contractor comes back and spreads more material on top, it changes the depth of the loops, and that affects accuracy. Another thing that can affect accuracy is whether or not the lenses of the thermal infrared cameras are kept clear. We get a lot of spider webs growing over them, and then all of a sudden you see your counts go kind of haywire. So a lot of it has to do with keeping the sites well maintained.
I know David Patton's on the call. I don't know if he wants to chime in about spiders, but Arlington has a whole bunch of permanent counters, and David has stories about spiders, I believe.
Yeah, hi David, I just unmuted you, so you should be able to speak.
Should I just talk at my computer here, I guess? You hear me?
Uh-huh.
Yes, we hear you.
Okay. Spiders, slugs, earwigs, pill bugs, ants. Yeah. I do the maintenance of the fleet of counters we have in the field. They're mostly permanent counters. They're mostly trail counters that count bikes and peds separately. We have, I think, 11 bike lane counters. We have 2 piezo devices. Everything else is inductive loops. And I carry a little spray bottle of boric acid with me when I go out in the field. And if there's evidence of insects, I give it a dose. It's an insecticide, but it's relatively benign to everything except insects. So it seems to work pretty well. Yeah, ants in our counters. And they will climb up into the nice, warm, dry part of a post and confound the infrared. So the infrared is not counting millions of little ants. It just gets confused and doesn't count anything. So you can watch the trace of the data on the website, and it'll either go flatline or it'll go off into the stratosphere, and that's a site visit. And I'm interested, the person, John, backing up just a moment, the person, John, in New Zealand said that they have a $400 a year budget for the first couple of years for maintaining these counters. That $400 gets eaten up by my cell phone bill. So I don't know whether you guys are getting a much better price in New Zealand than we are for the GSM service.
Yeah, it could be. I'm always amazed. On the other hand, there's only one provider of these services in New Zealand, and it's pretty hard to get them to call back. So I guess you get what you pay for. But yeah, it's 650 New Zealand dollars per year per counter. But I'll double check that because that's just what our asset manager tells me he's paying. So you could be right. It does sound pretty cheap, doesn't it?
Yeah, I tend to agree. I would say that with GSM service, with batteries that you need to rotate, even if it's not every year, every other year, I would definitely estimate more than $400 per counter for maintenance per year for us as well.
Okay, I don't see any other questions in the question pod right now. I guess getting back to the accuracy portion of this, and Frank, this might be more directed towards you. In terms of accuracy, the pneumatic tubes for the bicycle specific and the non-specific bicycle tubes, what sorts of differences in accuracy have you found between those? And anyone else is welcome to chime in as well.
Yeah, I mean, the bicycle-specific ones work better for counting bicycles, fortunately. I would hope it wouldn't be the other way around there. And they did seem to perform better in general. Although with the mixed traffic count, you get the benefit of being able to also count cars if you're interested in doing that. So I think with all of this, when you're thinking about accuracy, you need to weigh how much that accuracy is worth in terms of what else you might get either in lower cost or added things like being able to also count cars with some degree of accuracy.
Hello, this is Krista, University of North Carolina. Again, I'm just wanting to follow up on the pneumatic tube question. We looked at 5 different products in our study in Oregon and found that actually the bicycle-specific counter wasn't that much better than some of the other ones we looked at that were counting cars as well. And it was more of a question of where are they placed? Are they in the mixed condition where it's harder to count and differentiate the cars from the bicycles, or are they in the bicycle-specific location on a bike lane and just counting the bike lane, which is so much easier to do. Another thing that Boulder County found that related to accuracy with pneumatic tubes was that they found that they needed to make sure the pinching wasn't going on because the puff of air from the bicycle is smaller than the puff of air from the motor vehicle passing. So when they were anchoring their tubes, they modified how they were doing that to make sure it wasn't pinching the tube and that puff of air could get into the counter. Another thing that is of interest with pneumatic tubes is using mini tubes, and I'm not convinced that they necessarily improve accuracy, but they certainly reduce potential for trip hazard, and especially among skateboarders, if you have any of those who may be anywhere near the tubes, they do not like the regular road tubes, so using mini tubes can help there. And the Boulder County folks said that from their experience, they didn't really, they expected that they would have to replace the tubes more often, but in practice, other things were knocking out those tubes just as fast as the road tubes. So they didn't see an increase in maintenance fees for using mini tubes.
And thanks, Krista. I just actually, Sarisha, while you were talking, posted the link to your article. So I've now added that to the chat pod so that everybody has access to that as well.
Thank you. Thanks, Risha.
Yeah, no problem.
And if anybody else has done research on counting technology or accuracy of different technologies or anything like that, feel free to send me the link, and I will make sure that we provide that for everybody else as well.
All right. Well, at this time, I think if there are no other questions, and it doesn't seem like it, we're going to kind of move into the second portion of this webinar, and that's going to focus more on emerging technologies. So ones that are kind of out there that are being developed. If anyone's currently working on research with a specific technology that is still being developed, this would be a great time to chime in. You can talk about your research if you have any preliminary results. We were going to have Bernardo Pires from Carnegie Mellon Robotic Institute, but unfortunately he had last minute change, and so I believe Peter is going to discuss this portion of the presentation a little bit as he spoke with Bernardo.
Yeah, I don't have slides for anybody, but this was just something we heard about from Bernardo. He's a researcher in the Robotics Institute at Carnegie Mellon University in Pittsburgh. And he's got a program that can take your video that you've collected, however you've collected your video, and translate it into bicycle and pedestrian counts. My understanding is that he is willing to do that for governments and I think nonprofits at no cost for the foreseeable future, partly as testing for their algorithms right now. They're using an automated process, but it is with 100% human verification. So there are humans verifying these counts that the computers are tabulating. And he said they're currently seeing about 95% accuracy for pedestrian and bike counts with the video review that they've tested. And I think that's pretty much in line with what other technologies have been able to do. And it's certainly a lot faster than doing it by hand with interns and things like that. He said there are not any video quality requirements. If they have video that a human could use to review and classify bikes and pedestrians, they should also be able to use that. In addition to the bike and ped, they can give you car counts if you want that, and trajectories if you want turning movements. I believe they're able to do that. So they're hoping to get a web portal up soon for people to be able to upload videos and interact with them on that. But from what I heard from him, it sounds like this is a way that we may be able to get some counts using videos that we already have or videos that we can collect over short-term count periods. The one agreement I think he said that everyone will have to make is that data shared with them will be made public. That's a requirement for the grant funding that they're using right now. So I may not be able to answer a whole lot of questions, but I will try to get his contact information up in the chat pod.
Okay, great. Thanks, Peter. So just like Peter was mentioning, if you have any specific questions about this research, what we can do is basically aggregate those questions and either send them to Bernardo, or we can just provide you Bernardo's contact information so that you can ask him himself. We'll also post a recent webinar from, I believe, People for Bikes. They had a few webinars, and this is actually how I saw Bernardo's presentation as he presented on his ongoing research back in August. And so we can post a link to that as well, so you can kind of get an idea of what his research is doing. And if you want to see some of the other portions that are in that webinar as well, it was specifically talking about automated technologies and how that might interact with bicycle and pedestrian monitoring in the future. But we do want to just have a portion of time that's dedicated toward these more future sort of ideas, research that's currently being done. For example, has anyone done any research recently or is thinking about doing research, for example, with Bluetooth? If so, how has that worked? Or what results have you seen thus far? And also, if there's any particular research topics that you think might be interesting, posing those during this time might also be a good way to get a discussion or a conversation going. And I'll be sure to post Bernardo's or the link to his research or the project description page here in a few minutes. Okay, we just had question come in from Greg Lindsay. Automated video processing has been anticipated for some time. Does anyone of direct experience with any commercially available technologies? If so, what was the experience? So has anyone used any sort of automated video processing with any projects? If so, what did you find in terms of the results?
Yeah, hi, this is John Leeswin. We use a automated video processing, the most common one that comes out of Canada, I believe it is. They've got an agent here in New Zealand, and they just basically show up on site, establish the counters, usually a 24-hour count. So that can be a concern when you're dealing with walking and cycling, just because the variability in the flows is such that a 24-hour count might not really be representative of annual daily traffic. So it's pretty important to make sure that you get a good day. And usually we use it for project development. So rather than, more comparative year-on-year type trend analysis. So, but I have no reason to doubt the accuracy, although I haven't tested it. They claim that they do check it with a manual count to review the video and not just the algorithm itself. So, but yeah, that's my experience with it. We use it probably a couple times a month, various project sites.
Okay, great. Thanks, John. We just have another question come in just now. Can traffic detection equipment that's currently used at signalized intersections effectively collect pedestrian and bicycle volumes at an intersection?
This is Sureisha from Portland State University. So as Krista mentioned, we have done a couple studies now looking at using the existing infrastructure, specifically at signalized intersections, for counting bikes and peds, because there's a lot of interest from jurisdictions in using the infrastructure that's already there to reduce costs. And so what we found was that at least with the inductive loops for bicycles, it is really difficult to get accurate counts, especially in shared traffic, and especially where there is a lot of turning motor vehicle volume. With pedestrians, we were able to use the pedestrian push button activations to get an idea of the activity. So that is not demand, but it gives you an idea of at least a few pedestrians being there. So those were the two technologies that we have tested.
Suresh, there's also the thermal camera that we tested, and the I think there was one other. Why am I blanking? But I think our results, I believe, agree with what Frank was finding, that, or Frank already kind of covered that, but that we were having trouble in the mixed traffic situation getting accurate counts, and it just really wasn't working at all in the mixed traffic situation for us. But when it was bicycle only, then it worked very well with the thermal camera.
This is Peter. I just want to share something that David Patton sent me in a chat, that they, in Arlington County, Virginia, did a trial of Bluetooth sensors on an off-road shared use path. And their finding there was that the density of trail users with a live signal, so I guess that means people who had their Bluetooth on, was really pretty low. And I I can relate to that because before I got headphones that use Bluetooth, I never used my Bluetooth on my phone.
I would agree with that. This is Nathan, and I found that for myself. I would oftentimes have the Bluetooth off on my phone, just to save battery, and it's the same with the Wi-Fi. I would have both of those things turned off on my phone just to save the battery, and so I know that's always been a concern in terms of Bluetooth. I know this could change in the future, though, depending on how the quote-unquote Internet of Things changes and devices become more and more connected between one another. That sort of Bluetooth density might increase and might make that more viable, but I know at the time that's a significant concern, is just being able to have enough hits, so to speak, from Bluetooth to have some sort of manageable or have some sort of understanding of how many users are going through a certain area. And I want to say that was the case at the recent, at the NatMet conference back in last year. There was a research project that was done at a university, and they found, I want to say it was 20 to 25% Bluetooth penetration in terms of how many people they actually found that actually had their Bluetooth or Wi-Fi. They did a combination where they tried to see where people were going using those two different services. And even on a university setting, which you might suspect has a higher usage, has a higher portion of those things turned on for a phone, we're still somewhat relatively low in comparison. So this may change in the future, but in the current time, it seems to be something that still needs to be developed. Okay, we just had another question come in from Jeffrey McCullough. And he says, in testing and using equipment, was theft or vandalism an issue in your data collection efforts? And I don't know who this might specifically be towards, whether towards you, Sarah, or John. But did either of you find vandalism to ever be a problem with any of your devices?
This is Frank. I can speak to the NCHRP project. In out of probably 20 to 30 devices installed in the field, we had one lost due to vandalism. So it's an idea of our experience there. I know San Francisco has had a lot of trouble with their passive infrared sensors going missing.
Mm.
This is John. Not so much vandalism, but I did have one fire department call out, and they were a member of the public thought that our counter was a bomb, and so the fire department cut it off the pole. So yeah, make sure you label it property of traffic department or whatever, so that members of the public don't think it's something it isn't.
And David Patton says he's had some occasional vandalism, not usually destructive. Sometimes people are shoving leaves in the infrared port. I've heard of cigarettes being put out in that little port as well. Leaves can be pulled out. Other things may damage it. Sometimes people think it's a camera, and so they want to block it so that they aren't being watched.
Well, I can certainly understand those sentiments. But that's good that it seems that vandalism isn't as much of an issue. I know that I've spoken with some bike and ped officials around Florida, and it doesn't seem to be as much of an issue, even in some of the larger cities like Orlando or Miami. Their equipment, even the equipment that's out permanently, it doesn't seem that they really had as many issues. I think what a lot of the discussion comes down to today is installation, making sure that where you install it, the site specifically, how you install it, installing it in terms of having it be correct towards what the vendors specify. I believe if you do all place a lot of importance on those steps, it'll help negate a lot of potential conflicts that you'll have in the future. I don't see any other questions at the moment. I know this section was probably going to be a little bit lighter since we weren't able to have Bernardo on. Are there any others? Is there any other particular research that anyone else has seen, perhaps out there, or that they've been thinking about in terms of different technologies or newer technologies, especially related to the automated vehicles or some sort of automated technologies? What sort of new technologies do you think are out there at the moment?
It's hard to talk about them without saying their names if you don't want to talk specific vendors, but I've just in the last week came across one that's mounted to a light pole at 15 to 25 feet up and connects over GSM and is intended for the purpose of tracking or counting pedestrian, cyclists, or other objects as they move through the streetscape.
Right.
How is it powered?
That one can be either solar powered or connected to the grid.
And what about cost?
Yeah. I don't remember. That particular system was being used in, I'm going to tell you in a second, 3 U.S. cities: Jacksonville, Florida, Las Vegas, Nevada, and St. Louis.
Well, I can think of a potential or a research project that I believe is going on in FDOT District 7. I had heard about a project where they were trying to take current video feeds from traffic cameras and running them through an algorithm to try and see what sorts of bicycle and pedestrian data they could get from that. This particular vendor had developed a sort of algorithm, and they were able to, instead of having to put out their own specific cameras, they were able to just take the feeds and find the data or count the data in real time. And I believe that was a project that was either ongoing or maybe finished now. I'll make a note to look for it, so that way we can put that in the summary email for everyone, so that way we can, so that way that can be reviewed as well. Well, I don't see any other questions at the moment. So I'll just go ahead and go to the last slide here. We do have about 15 minutes left. If you have any last minute questions, you can go ahead and get them in now. But I would like to thank everyone for participating in today's webinar with the Conversation with Colleagues series. I'd like to thank everyone who's been on today and answered questions, provided a lot of insight towards one another. The next webinar, I believe, is tentatively scheduled for November 28th at 2 o'clock at the same time from 2 to 3:30 p.m. Eastern Time. And we'll provide more updates in the future as we get closer to that date. And we'll be sending out some more summary information with some links and resources and a recording, of course. And if there are no further questions, I believe we can go ahead and end the webinar today. Again, thank you everyone for joining. I believe this was very productive. We had a lot of questions, a lot of good answers today. Look towards our emails, and if you have any other questions, be sure to let us know, especially if you have any specific topics that you believe should be discussed between everyone here.
I do see one last minute question just came in from
Oh,
Jeff
yes.
about the software that's used to manage and distribute the data. Has that gotten any better in recent years? If you're trying to integrate data that you have from different vendors or share it with different agencies, are there folks that have insights into that are still on the line?
Well, this is Krista, Krista Nordback. When I was at Portland State University, we put together the biped portal where we put together data from different vendors, and that is still an ongoing project that Portland State University is continuing. So that's something that works. I know that other state DOTs are taking data from different sources. I just talked to Minnesota DOT. I'm not sure if there's anyone on the line from there, but if not, they mentioned that they are also, they have standard formats that they recommend for the different vendors in order to get some kind of consistency to eventually add those to a motor vehicle database. So they'd include the biped count into their standard motor vehicle database, but that's something that's still in the future for them. And that maybe Greg can talk more about that.
Can you hear me now?
Yes.
Yeah, I think that Krista described it well. Michael Pettish is the guy who's in charge of that. And it was MnDOT's objective over the long term to integrate all the bike and ped counts into their general database. They haven't done that yet, but they're available now, sort of as on a shadow system. But the data are being cataloged in format that's potentially updated. Their traffic database was in a period of transition when the firm they were using went belly up, and so everything was pushed back a couple of years, and they're still recovering from some of that transition.
Okay, great. And I know the Florida Department of Transportation, I believe they're trying to do something similar to what you mentioned, Krista, that Minnesota is looking into as well. But the various vendors and each of them having some of their different data formats always seems to be an issue. And I was wondering if anyone had any success with looking towards the TMAS format from FHWA, and if they notice any vendors specifically exported into that particular format, or if they had their own proprietary format that they used.
Sarah, are you still on? Because I think you're probably maybe the only one who's exported into that format. You and Scott Brady are the only ones I'm aware of.
Sarah had to jump off early.
Okay.
David Patton, he's just sort of waiting for the go signal to do TMAS.
My understanding, I haven't heard of any vendors who have that ability yet.
That's what I was imagining. I was just wondering if anyone had noticed that.
FHWA, I last talked to Jeremy Raw. They were trying to work on some script to help people do that, and I think they were working with Sarah on that. So I don't know if anyone else has information on how that FHWA effort is going.
Yeah, I think that's going to be the thing that makes it work, is when the software vendors say, have an easy button on there that says convert to TMAS format, and you can click that and send it on up the chain.
Yeah, that would be incredibly helpful if that was an option. So hopefully that is something that is looked towards in the future. And I don't see any other questions at the moment. I see David mentioning, or he had mentioned that waiting literally just for a button on someone's software. So hopefully that is done soon. Jeffrey, I believe is he unmuted now? It doesn't seem like it, actually. Yeah, Jeffrey, for some reason we're having trouble unmuting you. So what you can do is just send that to us, and then if anything, we can include that in the summary that we send out to everyone. All right. Well, I don't think we have any other questions. I think we've kind of hit a lot of major points. So I think perhaps for the next webinar, something we might do is seeing as we kind of are ending on this this note with data and data processing, that might be that might be the following webinar. I think that would be a good one to look towards. So look for more information from us in the coming days. We'll send out a summary and other information. If you have questions, just let us know. Again, everyone, thank you so much for being on today, and I hope you will have a good rest of your week. Thank you and have a good day.